All right, this is Unit 5, Lesson 4, Solving Radical Equations. So our lesson essential question is, how can you solve equations that include radicals or rational exponents? At the end of this lesson, you'll be able to solve radical equations and inequalities. All right, example 1, solve an equation with one radical. So solve the radical equation, the square root of x plus 5 minus 1 equals 3. To solve this equation, you can isolate the radical. Then you can square both sides of the equation to eliminate the radical and solve for x. The square root of x plus 5 minus 1 equals 3. Write the original equation. Okay. I add 1 to both sides, so I get the square root of x plus 5 equals 4. Then I square both sides, so I get x plus 5 equals 4 squared, or 16. And then I solve for x, so that gives me x equals 11. Check your answer by substituting 11 for x into the original equation. You can also check by graphing y equals the square root of x plus 5 minus 1 and y equals 3 on the same coordinate axis. The graph of the equations intersect at 11, 3. Solve the radical equation, the cube root of x plus 2 equals 4. I subtract 2 from both sides, and then because it's a cube root, I cube it, so 2 cubed is 8, so x equals 8. Substitute my answer back into the problem, and it works. All right, so let's try it. Solve each radical equation. Square root of x minus 2 plus 3 equals 5. So square root of x minus 2 plus 3 equals 5. I subtract 3 from both sides. Gives me 2. And then I square both sides. Squared equals 2 squared. X minus 2 equals 4. I add 2 to both sides, so x equals 6. Okay. For b, cube root of x minus 2 equals 2. I don't have anything to move to my other side of my equation before I look at this. So it's basic cube root. So cube root of x minus 1 cubed equals 2 cubed. So x minus 1 equals 8. So x equals 9. You should always double check and put it back in. 9 minus 8. 9 minus 1 is 8. So cube root of 8 is 2 equals 2. Should always substitute them back in. Example 2, rewrite a formula. The suspension cables from the Golden Gate Bridge's tower are farther above the roadway near the towers and closer to the roadway near the middle of the bridge. You can figure out your distance from the middle of the bridge, x, in feet, and the height of the suspension cable, y, in feet, at your position by using the equation x equals the square root of y minus 220 over 0.010583, which is the equation that they give us. About how far is the cable from the roadway when you are 200 feet from the middle of the bridge? So I rewrite the equation to isolate y so you can express the vertical distance between the roadway of the bridge and the suspension cable in terms of x. So x equals the square root of y minus 220 over 0.010583. I multiply both sides by that, which gives me y minus 220. I square that. So that's approximately 0.000112x squared. Y minus 20, I add 220 to both sides. So I get y is approximately 224.48. And then they substituted 200 because that's what 200. So the equation 0.000112x squared plus 220 is approximately y gives the vertical distance between the deck and the suspension cable for different values of x. So the cable is about 224 feet above the bridge's roadway when you are 200 feet from the middle of the bridge. All right, so let's try it. The speed v of a vehicle in relation to its stopping distance d is represented by the equation v equals 3.57 square root of d, What is the equation for the stopping distance in terms of the vehicle speed? Okay. So the speed v of the vehicle in relation to the stopping distance. I want to know what the stopping distance is. So I want to solve for d. So I have v equals 3.57 square root of d. So I'm going to divide both sides. So I have v over 3.57 equals the square root of d. So I have v divided by 3.57. Square that equals the square root of that's not correct. Square root of d squared. So that gives me b squared over b squared over 3.57 squared which gives me 12.7449 equals d. So d equals v squared over 12.7449. Example 3, identify an extraneous solution. So solve the radical equation, the square root 3x minus 2 equals x minus 4. Okay. So I write the original equation. I square both sides. So I get 3x minus 2 equals x squared minus 8x plus 16. Then I solve for 0. So x equals 9 or x equals 2. I check the potential solutions by substituting the solutions for x in the original equation. So 9 does work, 2 does not. So 9 is the only solution to the equation and 2 is an extraneous solution. So x equals 2 is an extraneous solution of the square root of 3x minus 2 equals x minus 4. Why does this extraneous solution arise? Your first step in solving the equation in part A was to square both sides to get the square root of 3x minus 2 squared equals x minus 4 squared. You now have two equations. Are they equivalent equations? Use the graph to represent both the square root of 3x minus 2 equals x minus 4 and 3x minus the square root of 3x minus 2 squared minus x minus 4 squared. The graphs of y equals the square root of 3x minus 2 and y equals x minus 4 intersect at 9, 5. So the solution is x equals 9. The graphs of y equals 3x minus 2 and y equals x minus 4 squared intersect at 2, 4 and 9, 25. So the solution is x equals 2 and x equals 9. So in conclusion, this means that the equations, the square root of 3x minus 2 equals x minus 4, and the square root of 3x minus 2 squared minus x minus 4 squared are not equivalent. Both graphs have an intersection point at x equals 9, but the second graph also has an intersection point at x equals 2. Squaring both sides of the original equation created an extraneous solution. So let's try it. Solve each radical equation, identify any extraneous solutions. So the first thing I need to do is square both sides. So x squared equals the square root of 7x plus 8 squared. So x squared equals 7x plus 8. So I get x squared minus 7x minus 8 equals 0. I need to factor this. 4, 8, and 1. So x minus 8, x plus 1. So x equals 8 and negative 1. So I'm going to substitute both of these in. So square root of, if 8 equals the square root of 7 times 8 plus 8. Okay, so 7 times 8 is 56, so 8 equals the square root of 56 plus 8. So 8 equals the square root of 64. 8 equals 8. So that is a solution. I'm going to substitute in -1. So -1 equals the square root of 7 times -1 plus 8. So -1 equals the square root of -7 plus 8. -1 equals square root of 1. So -1 is not equal 1, so that's an extraneous solution. So solution is x equals 8. X equals -1 is an extraneous solution. Okay. For B, I have x plus 2 equals the square root of x plus 2, so I'm going to square both of these. That's x plus 2 times x plus 2 equals x plus 2. X plus 2 times x plus 2 is x squared plus 4x plus 4 equals x plus 2. So x squared plus 3x plus 2 equals 0. So x plus 2, x plus 1. So x equals -2, x equals -1. So I have -2 plus 2 equals the square root of -2 plus 2. 0 equals the square root of 0, which is 0. So 0 equals 0. And then I have -1, so -1 plus 2 equals the square root of -1 plus 2. So that's 1 equals the square root of 1. So 1 equals 1. So they actually are both solutions. All right, example 4, solve equations with rational exponents. So what are the solutions to the equations x squared plus 5x plus 5 to the 5/2 equals 1? All right, so the first thing that I want to do is actually raise both sides to the reciprocal power. Okay, so I'm going to raise it to the 2/5. So that gives me x squared plus 5x plus 1 equals 1 to the 2/5 power, which is still just 1. So x squared plus 5x plus 4, because I subtracted the 1 from both sides. So I get x plus 4 times x plus 1. So x equals -4 or x equals -1. Check for extraneous solutions. They both happen to work. So they're both solutions. There are no extraneous. For B, what is the solution to x plus 18 to the 3/2 equals x minus 2 to the 3rd? Okay, so I want to multiply this side by the reciprocal power. So 3/2 to 2/3 cancels out, gives me 1. 3 times 2/3 is 2, because the 3's cancel. So I get 8x plus 18 equals x squared minus 4x plus 4, because I factored all that out. So I get x squared minus 5x minus 14, which gives me x plus 2 times x minus 7. So x is -2 or x equals 7. Double check for extraneous solutions. -2 does not work, 7 does, so -2 is an extraneous solution. All right, so let's try it. Solve each equation. X squared minus 3x minus 6 raised to the 3/2 minus 14 equals -6. So the first thing that I actually want to do is do 3/2 power. So I'm going to actually add -14. Add 14 both sides. So -6 plus 14 gives me 8. Now I'm going to raise a power to a power. Raise by 3/2. I'm going by the reciprocal, which is 2/3. So that equals 8 to the 2/3 power. Oops. Okay. That gives me x squared minus 3x minus 6 equals 8 to the 2/3 power is 4. X squared minus 3x minus 10. So that's 5 and 2. So x minus 5, x minus x plus 2. So x equals 5 or x equals -2. I double check for extraneous solutions. So I have 5 squared minus 3 times 5 minus 6 raised to the 3/2 power minus 14. Oops. That equals 6. So I have 5 squared minus 15 minus 6 gives me 4 to the 3/2. 14. 4 to the 3/2 power is 8. So 8 minus 14. 8 minus 14 does give me -6. So -6 equals -6. So 5 does work. My other solution was -2. So let's try that. So I have -2 squared minus 3 times -2 minus 6, and that's to the 3/2 power. It's 14, see if that equals -6. -2 squared is 4. 4 plus 6 is 10. Minus 6 is 4. So 4 to the 3/2 minus 14 equals -6. 4 to the 3/2 power is again 8. So 8 minus 14 equals -6. So -6 equals -6. So they are both solutions. All right, for letter B, I have x plus 8 squared equals x minus 10 to the 5/2. So what I want to do is actually square, well, I just want to expand the x plus 8. So that gives me x squared All right, letter B, x plus 8 squared equals x minus 10 to the 5/2. So I want to go ahead and multiply by the reciprocal of this. So x plus 8 squared to the 2/5 equals x minus 10 to the 5/2 is to the 2/5. So this gives me x plus 8 to the 4/5 equals x minus 10. From here, I'm actually going to go ahead and graph both of these equations. Okay. When I do that, I get these two lines. We can zoom out, and we can see that they intersect at 27.311 and 17.311. So when y is about 17.31, x is 27.31. X is approximately 27.31. All right, example 5, solve an equation with two radicals. I solve the radical equation, the square root of x plus 9 minus the square root of 2x equals 3. So when an equation has two radicals, I start the solution process by isolating one radical. So in this case, I'm moving the square root of 2x to the other side of the equation. I go ahead and square both sides, which gives me x plus 9 equals 2x plus 6 times the square root of 2x plus 9. I solve. I get pretty much, I isolate the other radical, and I square again. Okay. So in this case, I get negative x squared equals 6 times the square root of 2x squared, or 6 squared is 36 times 2 gives me 72. Then I solve for x, so x equals 0 or x equals 72. Again, you want to check for extraneous solutions. In this case, 72 does not work. So the only solution is 0. The value 72 does not make the original equation true, so it is an extraneous solution. You can also see this by graphing. So y equals the square root of x plus 9 minus the square root of 2x, and y equals 3. Together, they intersect only at the point x equals 0. All right, so let's try it. Solve each radical equation, check for extraneous solutions. So the first thing that I want to do is I want to get one of these radicals by itself. So I'm going to move the square root of 3x to the other side of the equation. Then I'm going to square both sides. X minus 2 squared. So this gives me x plus 4 equals square root of 3 times the square root of 3 is 3x. It's minus 3x times 2, so minus 4 times 3x plus 4. Okay, so I go ahead and isolate my second radical. So I get 4 square root 3x equals 3x is 2x, 4 minus 4 is 0. Okay, so I'm going to square both sides again. Equals 2x squared. 4 squared is 16. 16 times 3 is 48. So I get 48x squared equals 4x. 4x equals 4x squared. So then I get 4x squared minus 48x. I can factor out a 4x. So I'm left with x minus 12. So x equals 0 or x equals 12. I substitute both of them back in. The square root of 0 plus 4 minus the square root of 3 times 0 equals negative 2. So this gives me square root of 4 minus the square root of 0, which gives me 2 minus 0 equals negative 2. Well, 2 does not equal negative 2, so 0 does not work. It's an extraneous solution. Substitute in 12. So 12 plus 4 is 16. 3 times 12 is 36. So I get 4 minus 6 equals negative 2, which equals negative 2. So x equals 12 and x equals 0 is an extraneous solution. For B, I have the square root of x minus 15 minus the square root of 6x equals negative 3. So again, I want to move one of the square roots to the other side of the equation. I'm going to move 6x. I'm going to square both sides. Okay, so that gives me 15 minus x equals 6x minus 6 times the square root of 6x plus 9. Okay, so again, I want to get the other square root by itself. So I have 6 square root 6x equals 6 plus x is 7x. 9 minus 15 is negative 6. Okay, so again, I'm going to square both sides. I get 6 squared, which is 36. 36 times 6 is 216x equals 49x squared. 42 is minus 84x plus 36. I simplify, so 0 equals 49x squared. 4 plus 216 gives me minus 300x plus 36. I need to factor this, so I get 49x minus 6 times x minus 6. 49 times 6, yep. Okay. So that gives me x equals 6, or x equals 6/49. So again, I need to substitute these in. So I have 15 minus 6 minus the square root of 6 times 6 equals -3. 15 minus 6 is 9, so square root of 9 minus the square root of 36, which is 3 minus 6, which does in fact give me -3. Then I need to check the other one, 49, or 6/49. 15 minus 6/49 minus the square root of 6 times 6. 6/49. No. 6/49 equals -3. 15 minus 6/49 gives me the square root of 14.87 minus 6 times 6/49. No, that's not right. Heck. Yeah, that is right. Okay. The square root of 0.734 is free. So the square root of 15 minus is 3.85 minus 0.85. So I get 3, which does not equal -3. So 6 is a solution, but 6/49. So x equals 6. X equals 6/49 is an extraneous solution. All right, example 6, solve a radical inequality. The body surface area, or BSA, of a human being is used to determine doses of medication. The formula for finding BSA is BSA equals the square root of h times m over 3,600, where h is the height in centimeters and m is a mass in kilograms. A doctor calculates a particular dose of medicine for a patient whose BSA is less than 1.9. If the patient is 160 centimeters tall, what must the mass of the person be for the dose to be appropriate? So I substitute in the information that I have. 160.m, or times m, over 3,600 is less than 1.9. Write an inequality to represent the situation. I substitute 160 for h. I square both sides to get 160 times m over 3,600 is less than 3.61. Then I multiply both sides by 3,600 and then divide by 160. So m is less than 81.225. So the mass of the individual must be less than 81.225 kilograms for the dose to be appropriate. The graph of the inequality, y is less than the square root of 160 times m over 3,600, shows that when the BSA is 1.9, the mass of the individual must be less than approximately 81 kilograms. All right, so let's try it. A doctor calculates that a particular dose of medicine is appropriate for an individual whose BSA is less than 1.8. Remember, the formula for finding BSA is BSA equals the square root of h times m over 3,600, where h is the height in centimeters and m is the mass. If the mass of the individual is 75 kilograms, how many centimeters tall can he or she be for the dose to be appropriate? So I need to substitute in the information that I have. Okay. That means the BSA is 1.8 is less. Remember over here, we had this inequality. BS 1.8 is greater than the square root of the height, which we don't know, times the mass of the person, which is 75, divided by 3,600. I need to square both sides. So I get 1.8 squared is 3.24. Is 75h over 3,600. I need to multiply both sides by 3,600. So 3.24 times 3,600 gives me 11664. 75h, divide both sides by 75. I get 155.52. So the person needs to be 155.52 centimeters tall. Concept summary, solving radical equations. In words, I isolate the radical term, then square both sides to remove the radical, then solve the equation. Step 4, eliminate any extraneous solutions. So in algebra, it looks like this. I isolate the radical term, square both sides, solve the equation, check for solutions. You can also graph to see if you're correct or if you get stuck. So if you can't get rid of an exponential fraction or rational number that's an exponent, you can always graph to find the solution. And that is the end of Unit 5, Lesson 4.